Okay Angela, great lunch, but let's get back to looking at more of new wire sizing tool. Let's take a look at the sustainability part of this cool new Promisee and Bentley substation tool.
Still looks pretty nice outside. Dwight, this must be a really neat tool you're looking at. For just finishing a big lunge, you sure look animated.
Literally. Right?
Yep.
You're funny today. Okay, how about we go with a large motor load and a long conductor run distance?
Sounds good. That should tell us a lot about this tool.
Let's go with, let's say 200 horsepower. 463 phase.
That motor symbol right there on the left side of the screen. Let's say that's our 200 horsepower motor.
Okay, let me right-click on it. And I select wire sizing from the right-click menu. And a selection dialog pops up. Scrolling down to 460 volts and 200 horsepower, 3-phase.
Yes, let's go with the 200. There, select and it shows 240 full load amps. Yep. And it multiplies that value by 125% to obtain the maximum load amp value of 300 amps.
And that factor follows the NEC electrical code. That's good.
Nice. On to the next tab on the dialog. Okay, it has sized the minimum default wire size. Wire size 500 kc mil and those two small in red.
Right, the wire sizes where the maximum load current of 300 amps exceeds the wire's ampacity rating.
Gee, it would have been nice if the tool would have automatically suppressed those small wire entries. All the red ones.
Bingo. Just toggle off the Show All button right here.
Looks good.
Now we are seeing just the wire sizes that meet the code requirement for the 300 amp maximum load.
Nice.
Okay, let's change the wire insulation rating.
Let's say we were going to go with 75C wire insulation.
Instead of 60 degrees.
Cool. The higher temp wire now shows 400 kc mil as the minimum wire size. Nice.
Okay, if this thing has any chance of generating a voltage drop calc, we're going to need conductor length. Where do we enter that?
Yes, let's say that the motor load is going to be 750 feet away from the power source.
Ding ding ding. This toggle right here, and enter the run length in this box. There it is. The display adds some extra columns including voltage drop and, yeah, we can now see the kilowatt power loss in the wiring too.
Very nice. Everything recalculates with each selection. Won't we have significant voltage drop in this long run? Yes, in that fourth column. Looks like some significant voltage drop.
17 volts for our 400 kc mil wiring.
And the fifth column shows 3.77% voltage drop. But the tool shows how much each larger wire size brings that voltage drop down.
Hey, here's another filter. Look, you can toggle this filter to only show wire sizes that don't exceed a target percent voltage drop.
Okay, let's say we want the tool to automatically limit the wire selection to give no more than a 3% voltage drop in our 750-foot power run to this motor.
Cool. So if I select this filter toggle, I can suppress all of the wire sizes that do not have enough ampacity, leaving me with just the wire sizes that satisfy both the code ampacity requirement and a voltage drop not exceeding 3%.
It looks like we only have two wire sizes that meet both requirements. That 750 kc mil wire is large diameter. I've heard contractors say that it can be hard to pull. The 1000 kc mil is even worse.
And both are pretty expensive. What to do? Wow. Looky here. I can toggle this parallel wires option on. Whoa, will you look at that?
Look at all these new combos that are added to our two original, single conductor wire sizes.
Yes, and they all provide a voltage drop of 3% or less. I can go all the way down to 1 odd if I specifying 3 conductors per phase.
Very flexible. That would mean a total of 9 power wires of 1 odd instead of 3 power wires of 750 kc mil.
Okay, let's think about this. We can go with smaller wire, but we need 3 times as much of it. And the power losses in the wiring may be a factor too.
Yes, we need to consider wire energy usage losses and balance it against wire costs.
Usage, cost. Usage, cost.
Oh wow. You just hit the usage and cost tab. It adds some more columns. Looks like it's estimating the annual cost of energy loss in the power wiring.
You enter the anticipated kilowatt-hour cost in this edit box. Let's go with the 8 cents per kilowatt-hour default.
And looks like you select the annual amount of time this power is fed to the motor load.
Right, big difference if the large motor load is not 24/7. Let's just go with the default here. 8 hours per day, 5 days per week.
Nice. The rightmost column now displays the estimated maximum cost of lost electrical power for each conductor combo.
Scrolling down
to our single conductor 750 kc mil entry. Looks like annual loss cost of $436.
And I scroll up to the entry for the 1/0, 3 conductors per phase.
It shows an annual loss cost of
$821. That's cool. But we need to also analyze the relative increase in wire cost to go from the single conductor per phase to the multiple conductors per phase.
What's that toggle there? The one for wire cost. Turn it on. Let's see what happens.
Okay, looks like it adds another column to the display.
The relative wire cost for the various combos of wire sizes to handle our 750-foot run. Go down to our original single conductor 750 kc mil selection. That gives me a 2.9% voltage drop. Okay, it shows a relative wire cost of $54,000.
But if I scroll up to the top, to the 3 1/0 conductors per phase, giving me a 2.9% voltage drop, the relative wire cost is $16,000.
Wow, even though it's 3 times the total wire length, the relative cost of the smaller diameter wire is still about $38,000 cheaper. It uses an extra $400 of energy per year, on average, but the relative copper cost is $38,000 less.
Yeah, the skin effect kicks in. Saves on the amount of copper cross-section needed to pass the 240 full load amps, and pulling the smaller diameter wire instead of the stiff 750 kc mil stuff is probably going to save on the installation cost. And look at this 4th column. Raceway fill range. The tool is automatically taking into account a rating factor for the extra power conductors when multiple wires per phase is selected.
Amazingly cool.
So, it looks like using this tool just one time on this very large electrical load could help guide me in making a good, sustainable engineering decision that could potentially save $38,000 in copper wire cost.
Pretty good payback for selecting Promisee or Bentley substation.
Absolutely.
So, where does this relative wire cost come from?
Let me see.
Hit that wire cost editor button.
Yes, there it is. The various wire sizes are listed.
So it looks like we'd enter wire material,
Copper or aluminum,
and each wire size,
and unit length along with measurements in feet or meters.
And the rightmost column is probably the normalized relative wire cost used by the tool.
Let's go back.
Okay, there's a cost index edit box for the copper wire.
I'll bet you can enter in a different index value to anticipate future copper wire commodity cost increases.
Yeah, that makes sense. If you're making a sustainability decision on a new project but procurement is a year away,
you might bump this index up a bit to anticipate higher future costs.
The same goes for the kilowatt-hour cost. If the project is going into a geo where conventional generation plants are being phased out and replaced with renewables.
Right, so you might adjust this anticipated energy cost per kilowatt-hour cost up. Looks like the sustainability decision includes both anticipated annual energy cost values versus the wire costs,
and the option to economize with multiple smaller wires per phase.
All the calculations updated instantly as a help in guiding you in making both a decision that meets electrical code requirements.
And with an eye to sustainability, Bentley Substation and Promisee, looks like you have a very neat tool here.